Alright, so we start off with an atom. What makes an atom an atom? That's the atomic number, of course. And the atomic number, if you remember, is the number of protons. If I change the protons, whatever atom I have will no longer be that atom. The protons is what gives an atom its identity. So the first thing we're going to do is give the number of protons for each element that's listed. So all you have to do is look up the atomic number on the old periodic table and write that down. Go ahead and pause the video and do that. Alright, so after the atomic number, we have the mass number. And in case you forgot, lithium, there's a 3 on the periodic table. That's the atomic number. That's 3 protons. Now, the mass number is not going to be listed on the periodic table because the mass number can always change. If I have lithium, it comes in many different forms, so the periodic table can't tell me which form I have. But you're going to have some information. Now, there's 2 ways we can write that. Let's go with carbon. Now, carbon, if you find carbon on the periodic table, you see its atomic number is 6. There's a 6 right above it. Now, if we want to talk about what form are we talking about, we'll need some more information. There's 2 ways that'll be given to us. It could be like this. There's a 12. That's the mass number. We know it's not the atomic number because we look up carbon and it has a 6 there. So the atomic number is 6. And this number will be given to us. Okay, so the mass number. Well, what has mass in an atom? 2 things have mass in an atom. Protons have mass and neutrons have mass. Electrons have a small mass. It's too small to care about. So protons and neutrons, if we add those things together, the 2 things that have mass, we get the mass number. Alright, so there's our mass number there, 12. Another way you'll see it written is like this. And again, you have to remember this is the mass number. If you forget, is this the mass number? Is it the atomic number? Well, just go look at the periodic table. You'll see 6 is given. We know that's the atomic number. That's got to be the mass number. Okay, and these are called isotopes. Remember, isotopes just have a different number of neutrons. Now, that's useful because we can find the number of neutrons. So if we go back to our carbon, and let's say I tell you you have an isotope of carbon-14. Well, to find the neutrons, all you have to do is take the mass number, which will be given to you. Look up the atomic number on the periodic table and subtract those. Okay? Remember, this top number is protons and neutrons. This bottom number is protons. And so if we subtract that, P minus P is 0, and so we get N. So carbon-14 has 6 protons, 8 neutrons. That's all we need to know. Alright, so go ahead and work out these isotopes. There's carbon-14, I just did that. Go ahead and figure out how many protons there are and how many neutrons. Pause the video, finish those 4, and then move on. Alright, so atomic mass is not to be confused with the mass number. Atomic mass is the average mass. Whoops. So if I have a bunch of isotopes of something, let's say I have 3 different forms of carbon, carbon-12, carbon-13, carbon-14, the average mass will just be if I add them all up and divide by their abundance. You don't have to figure that out. You just need to remember how to find it. Okay? Atomic mass is average, and anytime I have an average, I'm likely to get a decimal. So if we just look up carbon on the periodic table, there's your atomic mass. Now, if you look at your periodic table right now, you'll see there is a key. So on the test, all you have to do is look it up. There's sodium. It tells you in the key in the top center, it tells you this is the atomic number, and it tells you this is the atomic mass. Alright, so those things are there. Use that for a tool. Alright, that's average mass. Now electrons, what you need to know about electrons, you need to know 2 electrons fill a shell, 2 electrons per shell, and you need to know what happens with electrons. And remember we said, here's the ground. We could call this the nucleus. The nucleus is down at the ground. Okay, there's our protons. Now an electron wants to be at the ground state. Okay, the ground is stable. It's closest to what it's attracted to, negative, positive. So he wants to be down there. But sometimes, here's my fire. Beautiful. My fire, some energy comes along. And this electron gets that energy. And he absorbs that energy. So he jumps up to a higher orbital. Now eventually this fire goes away, and this guy has all this energy, but he wants to be down here. And so he's going to fall back down. And when he falls back down, all of that energy he absorbed gets released. And it gets released in the form of light. Or, to be more technical, we could say, releases a photon. Alright? So understand that when an electron drops down, it releases the photon. There's no photon here, it's gaining energy here, but it's releasing the photon there. And every element, since they start at different places and move to different levels, every element has a unique spectrum, a unique signature. Alright, in classification, these are just some memorization things you need to do. Now remember, it's important for us for the group numbers. Now your periodic table has 2 sets of group numbers. You'll see like 17 over here. Okay, ignore those. We only care about the A's and the B's. And if you remember, the representatives are the A's. So anything with an A above it those are representatives. Anything with the B above it is a transition. So these guys in here are transitions. Alright, so 2 definitions. So using your periodic table for each of these, go ahead and label it as a representative or a transition element. Pause the video. When you're done, continue on. And then we have group names. Okay, we already said this is a group. 1A, 2A, 3A, 4A. Those are groups. And the names you need to memorize are these 4. Now it's nice, they're alphabetical. And so they go in order. This is group 1. This is group 2. This is group 7. This is group 8. So here's group 1, group 2, group 7, oops, and group 8. Alright. So if I tell you sodium, what group it's in, well, it's alkalides. If I tell you, I don't know what that guy's doing there. If I tell you fluorine, he's group 7. Okay, fluorine is a halogen, and helium would be a noble gas. Make sure you have those names memorized. Alright, go through these guys. Tell what group they're in, alkali, alkaline, halogen, or noble gas. Pause the video and continue on when you're done. Alright, metals and nonmetals, very important. Most of you got this. Metals and nonmetals behave differently. So on your periodic table, it has a line, okay, and that's going to separate. All of these guys are metals, nonmetals. Now if you forget which side is which, just look at some of them. Let's see. We have iron. Everybody knows iron is a metal, right? We have some copper here. It's a metal. Silver is a metal. So just look at these. You'll remember, these are all metals. That means these are non-metals. And of course we know that's important for later use. But go ahead and label each of these as a metal or a non-metal. Pause the video. Start it again when you are done. Alright, now periodic trends, this is the trickiest part of this section. Now with the trends, do not try and memorize them, but if you can reason through what's going on, then you can answer all of the trend questions. Remember, there's two trends, going down a group and going across. And the important thing to remember, if I'm looking at the periodic table, and I'm looking, what's my trend? What causes my trend as I go down? Well, my first period has one shell. My second period has two shells. And I go all the way down to period 7, which has 7 shells. Okay, so that's my trend. So I have to ask myself, how does adding shells affect a trend? And it depends what the trend is, but that's the overarching cause. Now, when we go from left to right, what's important? Well, as I go across, I'm in the same period, so my shells stay the same, but I'm adding protons. And so my strength of the nucleus is getting stronger. Okay, so weak to strong. And that's my important trend as I go across. Those are the two causes. Now let's look at the effect. There's 3 trends you need to know, and these two are exactly the same. So in essence, there's only 2 trends. Let's look at size of the atom. How are the causes going to affect the size? Well, we said the main factor going across is that it gets stronger. Stronger nucleus, stronger pull. And it's pulling the electrons. So this guy, pretty weak. This guy's pretty strong. So when my electron comes floating by, these 5 are going to pull it really close. When it walks by this guy, he's pretty weak. So my electron stays farther apart. Okay, so my size trend, actually this is larger and this is smaller. So my size decreases as I go across. And remember, as I go down, what's important? I'm adding shells. And so my electrons, I'm adding layers, right? If I have an onion, a little onion, and I add layers and make a big onion, well, this onion is obviously bigger, okay? So my trend as I go down, because I'm adding layers, my size increases as I go down a group. So it gets smaller going across, increases going down. And like I said, don't try and memorize it, understand it, and be able to figure it out, reason through it. All right, so given 2 elements, tell me which one is the larger atom. Pause the video and continue when you're all done. All right, electronegativity. Well, what is electronegativity? That's the attraction for an electron. Okay, I'm going to stop the video because I'm almost out of time. When you are done, or actually continue on to the second part of the video.